So welcome everybody to today's webinar, Building an Open GPU Cloud with Apache CloudStack, hosted by Sheibu. Before we start, a few organizational things. Today's webinar is going to be approximately 40 to 45 minutes. We will be getting questions on the Q&A tab, which you can see on the bottom of your screen. So wherever you have questions, just drop it there. You can also use the chat window. At the end of the webinar, we will spend about 5 to 10 minutes answering all of the questions. And we have some amazing speakers today. So we have Marco Signorelli, who is a CloudStack committer and a technical marketing manager at Sheibu. Marco has extensive experience in working with organizations implementing Apache CloudStack, so he combines both the technical knowledge and the business background about the needs of the users of CloudStack. He has been in the community for more than a decade so far. Our next speaker is Rohit Yadav, who is a CTO of Sheibu, and Rohit is one of the major code contributors to the CloudStack project, being involved in it from the very beginning, which was about 10 years ago, Rohit, or even more. And we have a guest speaker from US Signal, David Humes, who is the VP Product Development of US Signal. US Signal is one of the companies which have successfully implemented Apache CloudStack and built an amazing solution called Open Cloud based on Apache CloudStack. Today's webinar is going to focus on solving the two critical challenges for cloud builders. The first one being building a vendor-independent cloud and infrastructure as a service. And the second one, providing and delivering the performance which modern workloads demand so that you can be competitive on the market. We believe that CloudStack solves these challenges, both of them, but I will give the word to our more technical and more experienced speakers who can start and present. Rohit, I believe you're first.
Thank you, Vit. I thought I'll start with some introductory slides on what is CloudStack, because I reckon some of you who've joined us online are probably new to CloudStack. So what is CloudStack? CloudStack is an open source, scalable, multi-tenant, hypervisor agnostic cloud management platform. You can use CloudStack to build your own cloud. And CloudStack finds a variety of use cases in building private clouds, public clouds, edge clouds, or something in between, which is hybrid cloud, a mix of public, private, and edge clouds. This is what a typical CloudStack architecture looks like. If you see on a high level, it might look similar to the AWS EC2 architecture. At the bottom, you have the physical infrastructure, you have the compute network and storage infrastructure, and you typically put some kind of hypervisor on the servers. In case of CloudStack, because we are hypervisor agnostic, CloudStack currently supports KVM, VMware, Zen Server, and through the extension framework, it supports Proxmox, Hyper-V, and upcoming Canonical Mass. Underlying, on top of this infrastructure, CloudStack's control plane, the management server sets, which exposes an API. And on top of the CloudStack API, its CLI and UI are written. But a lot of people have also written third-party apps, e-commerce platforms, and portals using the CloudStack API. People have also built Kubernetes service. CloudStack has an internal Kubernetes engine called the CloudStack Kubernetes Service, but also external engines like CAPC, EKSA, and others. We also have a lot of support and integration with dev tools, like we have a Terraform provider, Ansible support, and automation through Chef, Puppet, and other configuration management systems. CloudStack also can be integrated with multi-cloud management systems. This is another way to look at CloudStack. You can see CloudStack is the abstraction layer. It's the layer between the infrastructure and the application and automation that can run on top of it. CloudStack abstracts the underlying infrastructure and exposes a powerful query-based API, which can be leveraged by UI, CLI, variety of integrations to build your own sort of cloud. So these are some of the advantages of CloudStack. Because this webinar is about the GPU, I'm going to list out CloudStack advantages, and other speakers, Marco and David's going to talk more from a GPU point of view. So overall, CloudStack is an open source software. That's a huge advantage. Not only it's just any other open source project, it's an Apache-based open source project, and it's user-driven. There are many open source projects which tend to be vendor-driven, and they don't take care of users' interest. I think CloudStack has clear advantage over those kind of open source projects. CloudStack is turnkey, easy to use. It helps cloud builders such as yourself attending this talk to build data local and sovereign GPU clouds. Uh, with this feature, the GPU integration feature, CloudStack is now a vendor agnostic IS platform, which gives flexibility and customization to operators and service providers. CloudStack is multi-tenant and it has self-service capability, including support for GPU instances with its rich UI, API, and plethora of integrations. Because of this, CloudStack has no vendor lock-in. There is no single vendor that controls the destiny of the open source project, and it lowers the total cost of ownership. So who are users of CloudStack? Now, these are some of the organizations who I've worked with or are known publicly who are users of CloudStack. Many of them are part of Fortune 500 companies, well-known companies that span across the globe. But because CloudStack is an open source project, there are many unknown users. And the reason for that is being an open source project, we don't track who's using CloudStack, who has downloaded CloudStack, and whatnot. In fact, some of the large customers and users of CloudStack that I've worked with, I can't name them simply because they didn't allow me, they didn't ask me to that. But to give you an idea, world's largest e-commerce company, world's largest consumer electronics company, and world's largest vaccination program, they were all users of CloudStack, but I can't name them for one or the other reason. From the public information we have, from user contributed list of names of organizations and company, we know there are more than 200 known large companies and organizations and users of CloudStack. In fact, in the last 1 year alone, CloudStack has been downloaded hundreds and thousands of times through a variety of IP addresses. Using that data, we've plotted something on a map for you. So we can see CloudStack users come from almost every part of planet Earth. CloudStack users are in more than 100 countries and thousands of cities spread across the globe. There's a nice QR code if somebody wants to scan, and it will take you to a link where you can zoom in and out and see in which city, place you can find your nearest CloudStack user. The CloudStack community today is a diverse user-led community. We have hundreds of active committers and PMC members who shepherd and lead the open source project. We have a very busy and active mailing list. We have a lot of activities going on GitHub. Here in the graph, you can see commit activity over the span of last 12 months. That said, we have a lot of activities going on in the community through meetups, events, and conferences. Now, that's just a quick overview of what the CloudStack project is all about. To kick off today's session, my colleague Marco is going to talk about the business case for GPU as a service. Marco?
Thanks, Rohit. Hi, everyone. I'm Marco from Shape Blue. Sorry, I'm a little bit ill. So what Rohit just shared as a solid technical foundation about CloudStack, and he will soon show live demo that brings the GPU integration to life. Then David will talk about how these capabilities align with the real market trends and customer deals. So my slides in that case just sit right in the middle of these two different perspectives, and I will share some numbers and business drivers that helps to explain why GPU as a service matter strategically, both from a technical perspective and also in terms of market opportunity. So let's start with this business drive. GPU as a service allows you to build a vendor-independent GPU cloud infrastructure. So you're not tied a single hardware provider. I think this is most important aspect when you decide to use open source technology. It delivers the same performance you have in the hardware and for completely different use cases and workloads. So this flexibility enable you to design your business for different billing models, for example, and consumption model. And cloud provider in that case can maximize the return of investment and unlock new revenue streams. This brings a clear competitive advantage across different industries. And this drive is translated directly into measurable business outcomes. This next, yes. So with Apache CloudStack, it's important to say that in terms of operation, it's really simple, and you don't need a large team. And so in that case, you reduce your total cost of ownership as well in terms of operation. And you have a lower TCO and return of investment, a very better return of investment. CloudStack is very easy to implement, and because of this, you have a faster time to market, so you can start to do business as soon as possible. It's very solid platform, and it helps you to reach your target faster. Next, please. Okay. So CloudStack supports a GPU discover and classification. It enables you to use one single GPU card per virtual machine, or you can share it into different GPUs using the single GPU card using the technology called the GPU. Rohit, you explain a little bit how it works in CloudStack after. So everything is fully integrated using the user interface in the API. So CloudStack, the nature of CloudStack is an open source nature. So in that case, you have a completely independence of the GPU vendor. So you can select the GPU that help you to design your business. Next week. In terms of market growth, so I did some research related to the market for GPU as a service. So I found these grand view search. So it's very interesting to see that from 2025 to 2030, we have a triple of the market size based on today. So it's I'm talking in 2030, a market with the size of 12 billion of US dollars. So this growth is global and well distributed across different continents. You can see, for example, in the graph that each continent have similar growing during the time. So and this growth is driven by a few cases of use that I will show right now. So as you can see, artificial intelligence and machine learning workloads represent around 65% of the GPU demand for today, both training and also inference. So other use cases continue being important, and so like high performance computing, VDI technology, gaming, media workloads, and others. So, but the most part of the use case today is related to artificial intelligence and machine learning. So, and to be honest, when it comes to a real world use case, after David can show that has way more authority than I do. So David, you can show better. So I will let him to tell his story later. Sectors driving GPU demand. This demand is coming from multiple different industries. So from financial services and healthcare to media, manufacturing, and telecom. That means GPU as a service isn't a niche play. It's becoming a real mainstream, as you can see, different sectors are using artificial intelligence for different use case. So the next, you explain a little bit about the use case you have that these sector are using. It's so finally, here how these workloads translate into a real cloud use case: artificial intelligence in training and inference, GPU accelerated VDI for many different of workloads, cloud gaming. I think the cloud game is the the GPU as a service is starting with cloud in game, and so you can see for other kind of use case as well. HPC simulations, analytics, and so much more that needed to use a GPU as a service. So you don't need to have an upfront investment just to have it running in your own infrastructure. I think to share the time you have of GPU between different customers make completely sense. Yeah, so that's it. I think it's with you that right now, right?
Yep. Thank you, Marco. So I thought I'll do some slides to give a bit of context on the GPU integration, how we developed this feature, what sort of thinking went into that, what are the technical capabilities we ended up implementing, followed by a demo. So this is a joint collaboration work done between US Signal and ShapeBlue. We've delivered a technical preview which shipped in the CloudStack 4.21 version. And in the upcoming 4.22 version, we think it's fit for production. People can start playing with this in their staging and production environments. This feature was done in a way that we wanted flexible and GPU vendor agnostic support with KVM in CloudStack. And the reason is we started looking into the GPU vendors in the market, and we see NVIDIA, AMD, and Intel are the three large companies who are sort of driving the market. With NVIDIA, the current undisputed market leader, but we recently are seeing AMD sort of rising to the competition, right? They are the growing contender, and seems like even Intel is trying to catch up. So we wanted to build an integration in CloudStack so that's not specific to a specific vendor or even models of GPU. For that, we surveyed the GPU vendors, tried to understand the GPU technology, which is how a physical GPU card can be shared, splitted, or sliced to be consumed by virtual instances. So here we see pass-through is the very obvious one, where an entire GPU can be fed or attached to an instance. But we also found other technologies. But we found that there's no single GPU technology which exists right now. Every vendor, every GPU model, in fact, card has their own sort of details on how they sort of accomplish that. So we thought, okay, we can classify GPUs as two large types. One is the GPU pass-through use case, where you want full GPU access with an instance of one or more GPU cards, or you want virtualized or shared GPUs with your instances, where the partitioned, shared, or sliced physical GPUs are attached to an instance. And we thought, let's do it in such a way so that it's not only vendor agnostic, but it's also hypervisor agnostic. So we implemented the GPU framework at the lowest levels of this architecture so that all the upper layers can benefit GPU. By starting the initial support with KVM, we not only have GPU-enabled instances, but all the other layers, whether it's consuming infrastructure through API, UI, automation, they can all leverage GPU-enabled instances. This is what on a high level sort of it looks like on a per host basis. So on a KVM host having multiple GPUs, we want to be able to attach a physical GPU, i.e. a dedicated GPU, one or more GPUs to an instance, but we also wanted an ability to use virtual GPUs or vGPUs. In this example, you can see the NVIDIA vGPU manager has sliced and partitioned a physical GPU, which can be plugged to one or more instances. We want to do the same thing for instances for Kubernetes. And Kubernetes through CloudStack, whether it's being deployed using CKS, CAPC, or EKS-A, it also ends up deploying what we call Kubernetes worker nodes, which are nothing but instances. By having the same topology available to Kubernetes worker instances, pods, the Kubernetes pods can have access to GPU resources as well, and you can unlock a lot of use cases with this sort of a setup. In terms of design and architecture, CloudStack Management Server is the control plane that sits. It has its own API. It powers the UI and a CLI and third-party tooling, automation, and ecosystem of tools. We run a CloudStack KVM agent on the KVM host, which has access to customizable hooks that I'm going to talk about in a second. And using this sort of architecture, the control plane can talk to the agent and orchestrate instances with physical GPUs or virtualized GPUs. We wanted to enable self-service with this feature. So for that, we introduced tenant GPU limits, where a cloud operator or a cloud builder can specify the tenant limits on a per account, domain, and project level. And to maximize utilization, we also introduce a behavioral flag where operators can say what happens when instances are shut down, allowing them, for example, to make the GPU devices available to other instances when a GPU-enabled instance is sort of shut down. In terms of for enabling billing and billing API and other purposes, we've basically leveraged the CloudStack usage feature by simply tracking the running VM and allocated VMs in CloudStack, which are mapped to GPU-enabled service offerings. Cloud operators and service providers can bill their end customers for the GPU instances that they run. For host allocation and orchestration, CloudStack has its own deployment planner, which now takes care and understands GPU host inventory, a feature we'll see in the demo in a second. So by knowing about the GPU inventory in the infrastructure, knowing about the service offering, CloudStack can make intelligent allocations of instances with GPUs based on the inputs which are provided by users. To enable customization and flexibility for operators and cloud builders, we looked at, okay, what can we do so that every time there's a new GPU vendor, a new GPU model, we don't need to modify changes in CloudStack. For that, we introduced some hooks, which we call the KVM agent hooks. The first one is the GPU order discovery script. This is a operator customizable script that you can customize on per KVM host basis. So each host can have heterogeneous set of GPU cards, vendors, models, what have you. And this script basically reports the inventory to CloudStack Management Server. We also introduced some hooks so operators and cloud builders can customize how the domain is transformed. In case of KVM, virtual machines or instances are called domains. And using these scripts, operators can define how a GPU can be attached or detached to an instance. So for example, in certain niche cases, you might need to configure an out-of-band system, a proprietary vendor-specific tooling mechanism or APIs when you attach and detach these GPUs to instances. These hooks make it flexible for operators to configure, pick and choose, and customize how GPUs are allocated to instances, and if they need to put in their own custom secret sauce or logic when instances are started, stopped, or initially created. So time for the GPU demo. I don't have a recording, and I thought it will make the webinar a bit more exciting. What I have here is a locally running version of CloudStack 4.21 release. I'll start with as a user. So whatever you see here, it's all live. Let's just pray to the demo gods. If things go wrong, I think at least you'll be entertained. So let's start trying to log in as a normal user. This is what your tenants will see. So all the cloud builders and CSPs on the call, this is what the tenant will see. As soon as they log in, they are greeted by a nice dashboard where you can see a brief glimpse of variety of cloud resources. You can see limits here. So in case of compute, storage, and network. So for example, I already see GPU here. So the tenant limits we talked about earlier, this tenant that I've logged into, test user, has 20 GPUs allowed, out of which 2 are consumed. So that means I'm running an instance with perhaps 2 GPUs. So this gives a glimpse of what sort of limits are allowed for a tenant and what is the consumption for that user. We can start by creating an instance. By creating an instance, you start by selecting a GPU-enabled zone. Then you can select an image of your choice. Now, this is a simulated environment. So we're not using actual KVM host, but we're using a simulator just to prove the idea that this is a GPU, this is a hypervisor agnostic GPU framework. So here we start by picking any operating system. Let's pick Ubuntu because that seems to be popular. And then here, operator and cloud builder configured compute offerings will show up here. So here you can see we have an option to say show only GPU enabled offerings. So you can filter out offerings that are GPU enabled or not. Here you can see details of the GPU. So these are again simulated cards, but you can imagine this can say an NVIDIA card or an AMD card or an Intel card, right? You can say. You can also see the number of GPUs. So this is basically to say you can configure service offerings which have one or more GPUs also. So we start with the basic one, the small instance with GPU. You can put in a data disk if you want. Tenants can select or create their own networks. They can select SSH key. I'm going to give it a name. I'm going to just say user demo 1, and I'm going to click on launch. Then I can go to the instance, and you can see user demo 1 is already deployed. So as a user, existing users of CloudStack will see that nothing has changed. Their workflow, the user experience, all of that is same. The only thing different we have done is we've introduced GPU as a first-class framework offering that integrates with existing features, which is instances, dashboard, tenant limits, and whatnot. If you go to the instance here, you can scroll down to the left side. You can see if a GPU is enabled. Also, if you go back to instances, you'll see this GPU enabled label. So instances that don't have GPU will not have this label or flag, and instances with GPU will have details like this here. They'll also have a tab here called GPU. So here you can inspect that, okay, I'm using a particular offering of GPU, and I've got 2 GPUs available here. If I go to my own account, so let's say if I go to my account here, and I can click on limits. There also I can see tenant specific limits, and then you can clearly see the GPU limits. So since I've deployed 2 instances, both the instances have 2 GPUs attached, I can see 4 GPU resources are consumed and 20, out of which 20 are allowed. Now that was for the end user. What about how do you actually make it happen, right? You all may be wondering, okay, how do you configure this thing in the first place? Let's try to log in as a root user, the admin user account. And here you can see a different dashboard layout. So for all across your zone, you can see the different infrastructure information. You can see the compute information. Here you can see that you had 40 GPU resources available in that particular zone, out of which 6 are consumed because 4 are consumed by a user, 2 by an admin that we'll see in a second. If you go to an account, let's say we go to this particular account. So here, earlier we saw the GPU limits here. Now you can configure limits. So you can say this particular account is allowed a specific number of GPUs. So here, instead of 20, you can configure on a per account, per tenant, project and domain basis these limits. So how do you actually configure these GPUs? You start by adding a KVM host. For example, I've already have some KVM host added here. So I've got 2 clusters, C0 and C1. 2 of them, each of the cluster have 2 hosts in them. And you can see some host says GPU enabled, others don't have them. If you go to the GPU enabled host, now we see a new tab called GPU. And also on the left side, you can see the number of GPUs available on that particular host. If I click on the GPU tab, it gives me a summary of what are the different cards which are available, how many of them are allocated, how many instances are using those GPUs. So in summary, for example, you can see there are 2 instances running, 4 GPU devices are allocated. How do you discover them? So there's a button called discovery. In fact, let me go to a host which doesn't have GPUs. So you can see there are no GPUs here. It starts with users on having existing infrastructure. You may decide to put in GPUs. All you need to do is click on this button. What this will do is it will execute the GPU discovery hook that I've talked about earlier on that specific host. In case of simulator host, all you see are simulated behaviors. I click on discovery and I can see the devices are discovered and added to this particular host. If I go to the GPU devices tab, so first is the summary tab, but if I go to the GPU devices tab, here I can see the actual GPUs. In fact, I see the GPU pass-through. So some of them are the pass-through profile, which means these are GPUs that you cannot virtualize, you cannot splice split or share, but some of them can be split. So in this case, you have a physical GPU card here, but you can see that this physical GPU card is splitted or spliced in different virtualized GPUs or vGPUs. Similarly, you can see on a particular GPU basis, you can see information on whether it's free. So here you can see it's free. we'll see examples of, let's say, this particular host which have instances running. So for example, I've deployed a few instances earlier. You can see that this particular GPU is allocated to particular instance. In fact, if I can click it, it takes me to that instance. Now, as an admin, when I go to the GPU tab for an instance, I see a different new tab, and this is for the operators only, where you can click on it and it tells you what are the GPU cards attached to this particular instance, where are those cards, what is the profile of that GPU. In fact, if I click on a profile of an instance of a GPU, then it tells me the RAM and other information for that GPU or vGPU. Let's head back to the host. So we are going back to the host now, GPU devices list. Now you may see there are actions available here. So for example, if you have heterogeneous set of GPUs and some you want to orchestrate through CloudStack, some you don't want to orchestrate through CloudStack, you can select them and you can say unmanage. You basically are saying that these two GPU cards or devices cannot be used by CloudStack to orchestrate and attach through instances. You can also decide to delete them. So you can decide to delete them, but of course, it does calculation and check, so it will not allow you to delete GPUs which are in use. So that's the GPU inventory management. Once you have done the GPU inventory management, you can also do GPU classification by going into service offerings, going into configuration. And then here you can see different GPU cards. So if I see this Pro card, you can see a variety of profiles here. It's like, how do you splice a particular GPU card? This is all automatic. The CloudStack builders and CSPs don't need to define them manually. However, we do give them knobs and control if they want to create it manually. So the way you can do it is you can add a profile here, and then you can go back to your particular host and you can change a particular profile. So this allows you to maybe in later form, once GPU becomes a commodity, not a niche hardware, you can edit and you can basically change a profile that will be listed here. This is all automated. If the discovery happens correctly, none of this is something that you need to create. Okay, fine. So now we have understood how VM instance lifecycle, tenant limits, and host inventory works. How does cloud how can cloud builders actually create configurations or service offerings? For that, you can go to compute offering. You say, I want to add a new compute offering. Let's just call it demo GPU demo offering. You can give it any core. So I'm going to just put in some small numbers here. And here you have a GPU card. This is a new drop-down we've added. Here you can select the GPU cards which are available unique to your environment. Because of the GPU discovery, CloudStack understand and has auto-discovered variety of GPU cards which are available, which are unique to your infrastructure. So once you have added the GPU cards, they will automatically come and list here. You don't have to manually add them here. If you click on basic has only one profile, which is pass-through, which means this is a type of GPU card which cannot be virtualized. If you select Pro, then if there are GPU cards which can be virtualized, all those partitions will show up here. For as an example, I'm going to just select this, and you can also specify GPU counts. I think traditional modern KVM domains can support up to 16 GPUs, so you can put up to 16 if you want. But for case of our demo, I'm going to just put, let's say I'm going to put 3. For vGPU VDI use cases, if you want your instance to use the GPU for rendering the display, you can turn this thing on. So I'm going to click on OK to create that offering, and that's it. Once I've created my offering, cloud builders can upload templates which have the GPU specific drivers installed, or users can install those drivers later on as well. Users can bring their own templates, their own ISOs and whatnot. Once that is done, all that is remaining is to add an instance. So now again, as an admin or a user, all you need to do is select your uploaded template and ISO, select the offering. So this is the GPU demo offering is the one we just created with the 3 GPUs, right? And then you can select the network, you can select SSH key, give other options. And I'm going to say admin GPU2, and I'm click on launch instance. And if everything goes well, we'll have a new instance using the new offering that we have created. So here you can see that this instance is running on host sim 3. If I click on it, on the GPU, you can see there are 3 GPU devices attached to the instance. And here I can see the details of the instance, where on which particular host that is running, and other nuance and details of the feature. That's basically the feature, the GPU integration feature demo. And I'm gonna head back to the slides now. And I'm gonna introduce David, who's gonna talk about the integration work and how Open Cloud and US Signal is leveraging CloudStack's GPU integration feature. Over to you, David.
Fantastic. Thanks, Rohit. The demo gods viewed you favorably today, it sounds like. No Mark Zuckerberg demo from a few weeks ago, so that's good. So yeah, as Rohit mentioned, we've obviously been partnered with ShapeBlue really since the inception of Open Cloud, which I'll give you a little bit of a primer on. But in particular, we've been working hand in hand with ShapeBlue and the community on adding this functionality. So just a bit about me. I'm the Vice President of Product Development here at US Signal. We're an infrastructure provider based in the United States, which is where I'm based. My background is predominantly actually as a customer. So we have a very strong customer focus when it comes to US Signal. And I live in Minnesota in the United States, which it's almost winter, so get ready. And a bit about US Signal. So we are a data center infrastructure and network provider based in Grand Rapids, Michigan. We're founded in 2001. Again, we view our core competencies as a business as really connectivity to the data center and between the data centers. Security managed services and cloud are what we consider our one-step adjacencies. So one of our imperatives is that we don't stray too far from the core. We want to be the best at what we do. We're not trying to be sort of everything to everybody. In terms of the footprint, we currently have 16 data centers spread across the United States today. We're currently expanding 2 of those in what we think of as edge markets, which means sort of tier 2 cities, typically non-NFL type cities. And then we have 8 micro data centers under construction along 1,000 miles of fiber, which we're currently constructing. So the 1,000 miles of fiber will add to about 9,500 route miles of fiber that exists today. We've got 3,000 customers across the United States. And in terms of our cloud platforms that we support, Open Cloud, which we're obviously here to talk about today, we also have a Nutanix-based product called ReliaCloud. And then we also do have a Microsoft Azure CSP and MSP offering. And our technical operations center is based in the United States, staffed by engineers 24/7. Our customers love that because it gives them the ability to call in and get somebody who can really help. So a bit about why we built Open Cloud. So, when we think about both our customers and kind of where the cloud market is, you see this technology adoption lifecycle. Our customers tend to be in the late majority to laggard category in terms of their adoption from an enterprise IT perspective. And so similarly, as we built Open Cloud, we've had to cross this chasm with our customers to bring them from thinking about Open Cloud to really purchasing it. And that's really as a result of changes in work culture, which is heavily work from home and hybrid. It's the need for high network resiliency. And then on the economic side, it's really this shift that's been happening for 10 or 15 years from heavy CapEx to heavy OpEx. But a lot of our customers are really spending their time focusing at the application layer and less on the infrastructure side. And so that's really why they turn to US Signal. And then there's some broader technology trends that I think everybody is quite aware of. But the truth is, we were thinking about what cloud and private cloud would look like really actually before the VMware shakeup. So everybody knows that Broadcom bought VMware, had major price increases that I think caused a lot of enterprises in the United States to realize they were really single-threaded. And so we're seeing a ton of customers migrating from VMware, whether it's our VMware platforms or competitors, to the Open Cloud platform. But at the same time, we never thought that VMware was really the true cloud product that it was touted. The hyperscalers like AWS and Azure have really figured that out. And that's why you've seen such growth. And this is the ability to go in and provision infrastructure without having to bring your service provider with you in the process, just the ability to consume as you go. And so this is why we think that Open Cloud powered by CloudStack is really the future of cloud. So how do we know this? We know this because we ask our customers, not because we think it's the right thing. So back at the beginning of 2024, when there were rumors around what was happening with VMware, we pulled our customers together. This is our office in Grand Rapids, Michigan, which is where I'm at right now. And really, they told us, look, we don't really care about the underlying hardware. We don't really care about the underlying virtualization platform. What we do care about is price. We care about performance, security, compliance, and SLA. And so, for OpenCloud, because it's powered by open source platforms, because we were smart about how we built the platform from an infrastructure perspective, we're 30 to 40% less expensive than our competitors. And that is a delta that causes ears to perk and people to have conversations. And the good thing, though, is that it's not just price competitive, it's also super performant. So we built it on enterprise infrastructure, R650XS servers, Arista spine leaf switching, all flash InfiniBand NFS storage. So it's not just competitive price, it actually performs well. And we've proven the performance out with some third-party assessments of the infrastructure, which shows that we perform extremely favorably against our competitors. And then, of course, security and compliance, which are not the same thing, but they get looped in, and that's what I'm going to do. We have customers in highly compliant industries, and so we've actually been able to find that OpenCloud with CloudStack under the hood is really able to be as compliant as really anything else. But what our customers told us is that if they don't care about hardware, they care about the SLA, and so we give OpenCloud 100% SLA. So why OpenCloud if you're a customer, right? So I mentioned that flexibility piece. It's unique if you're coming from like the VMware vCloud Director ecosystem, which is a lot of customers are doing. They get provisioned pre-canned quantities of memory and infrastructure, and if they need more storage or more memory, they have to call their salesperson or go through a process. With OpenCloud, it's really the ability to go and deploy infrastructure as the business needs. So, but you still get that control of a private cloud environment. You know where your data is. Obviously, it's cost effective because it is based on open source software. We all know open source isn't free, but it does help us control the underlying cost structure for the long term, which is what we wish to be with our customers as long-term partners. And then I already mentioned compliance. So we're SOC 2 Type 2, PCI DSS, and HIPAA compliance, which for the majority of our customers are the compliance attestations that they need to do their business. And then I think the beauty too is in the simplicity, right? You saw the GUI that Rohit walked through. It's pretty simple and straightforward to use. You don't really give much up. At the same time, if you're going to leverage infrastructure as code and use the APIs are super strong to be able to do that too, which more and more of our customers are really looking for. So, what are the advantages? Obviously open source and build sovereign IaaS clouds, no vendor lock-in. Again, there's a lot of hesitancy, particularly in the United States, around vendor lock-in post the Broadcom world. And so our customers are looking at us not just to do that from a virtualization perspective, but really all layers of their infrastructure needs. Flexible integration, GPU vendor agnostic. You saw the ability to do NVIDIA, AMD, Intel. Again, we're going to go where our customers want us to go. So that probably doesn't always mean deploying H100 or H200s. There's probably subsets of GPUs that customers really want, and that'll let us adapt as needed. And then again, because we built the foundation of this house on something that is really strong, really performant, but also lower cost, that translates as we build things on top of the CloudStack and OpenCloud ecosystem. And then just about a little bit about where OpenCloud is going. So, we launched OpenCloud just about a year ago today. We've got 80 or so customers on the platform. We're migrating more and more every day. We didn't just launch it and let it sit still. We're really looking at bringing it at least up to feature parity and then beyond feature parity as we add platform services. So back in July, we launched a desktop as a service or VDI platform, runs right on top of OpenCloud and CloudStack. So again, we get to leverage that those unit economics and provide really powerful desktops. And for our managed service provider customers, that's a huge benefit because they love providing that service to their customers. We're just a week away from launching a disaster recovery as a service product, which is a hypervisor agnostic solution. And most of our customers are going to be targeting OpenCloud with that. And then through the rest of the year, we're going to be adding ARM virtual instances using 192 core Ampere CPUs, really identified for the SLM use case optimization. And then, of course, GPU as a service, which are here today. We're excited about it, not just because it's going to enhance the desktops that we just launched, but also everything else that's coming forward when it comes to things like AR inference and training we're required. And then Last but not least, we're deploying Open Cloud today predominantly in multi-tenant environments, but we have customers asking us to put it in their data center. And so we're pursuing what that will look like as well.
Thank you very much, David, Rohit, and Marco. Very insightful webinar. Great demo for Rohit. Good success, and also amazing success story of your signal with CloudStack. So we have included a few links with some resources which you might find useful. After the webinar, we will be sending the presentation and the slides, so these links would be available to you. If you're wondering how to start with Apache CloudStack, the mailing list is a great place to start, or just join us in November in Milan for the yearly CloudStack Collaboration Conference, which is the biggest get together of the CloudStack community, where you can meet a lot of engineers and people who are using the technology and who can help you and share experience. Thanks again, Rohit, David, and Marco. It was great presentation, and all these amazing speakers you can see on the CloudStack Collaboration Conference in Milan in November. So if you want to meet them live and talk about CloudStack, that's the place to do it. Thank you very much and have a lovely day.